Yeah, good morning. Welcome to the third lecture of the programming workshop. What are we going to do today? We are going to recap on assignment 3. We are going to talk about benchmarking and unit testing. First of all, status review. Everyone is a group. Well done. Everyone is in a group. Well done. What happened? What happened last week? I think there were 10 hand-ins in total and 8 groups solved assignment 2 correctly. Well done. And a few tried already parts of assignment 3, and there were varying results in what they tried to accomplish, and we'll talk about this in the beginning. I looked at the hand-ins half an hour ago, and I think only 4 groups submitted a hand-in. Yeah, and that's way too few. Yeah, I think you should try to produce these hand-ins and try to get a review on your code and some feedback on your code. And there's this deadline. Like if your group didn't finish assignment 3 by end of October, I and the TAs are going to talk to you about what has happened. Yeah, and so if you can't finish that, then it's the question, can you actually finish all these 6 assignments until beginning of December or mid-December? Okay, just to tell you, so to hand in, what you do is you work on your code. You have a certain how to say, yeah, you worked on your code. You reached a certain goal, hopefully, yeah, and then you want feedback on that, yeah. And what you can do in the beginning is you just go to learn it, and you see the optional hand-in here, and I'm going to put an optional hand-in for next week there as well, and for 2 weeks after that, and you can hand it in like over here. Was it for this time? You click on it. It would be best if you produce a single zip file, and then you hand it in, and we give you feedback on that. If you already want to do it on GitHub, a few of you tried and that worked pretty nice. There is a hand-in procedure over here which tells you how to do it on GitHub. Of course, if you don't feel like you can work with Git now, then this is not for you. Yeah, but in 2 weeks, so next week is autumn break, but in 2 weeks we are going to talk about Git, and from that point on, like the first hand-in that is. End of October, the first hand-in is only on GitHub. Yeah, then there is no Learn It system anymore. Okay, you can find the description here. Do you have questions about this hand-in system? Yeah, it feels like 4, I think it was 5 now. 5 submissions is a bit too few. Yeah, you should maybe try to work harder. But let's see. No questions. Yeah, but it's just, yeah. You should really try to work with the code. If at the end of October you're still unsure how this prototype works, then you're really in trouble. Like your whole group is in trouble. Okay, that's about the hand-in system. Let's recap assignment 3. So we did this basic prototype, and assignment 3 was about providing a very nice index for your search engine. And what was an index? Well, the index was a very basic data structure to support the following type of task. Given a word, what are all the websites that contain that word? Yeah, that is the very basic task of your search engine. A single word, what are the websites? And we did a simple index, and we're going to do some live coding on the simple index with the prototype. That is one kind of index, but what I want you to implement is an inverted index, and that looked like the following: that with each word you just associate the list of websites where this word occurs. Okay, so Copenhagen, website 1, website 3, and university and off. And basically what you want to do, what is the data structure here? The data structure is a mapping between a single string, that is a word, and a list of websites. This list over here. Okay, and you learned it in your introduction and programming class. Such a mapping can be achieved by using this map interface, and there are many different implementations of this map interface, and the 2 of them you should use are, or you you should at least implement to finish the assignment is TreeMap and HashMap. Yeah, if you look at are there more map implementations, you can just look it up in the documentation of Java, and there are more. And you can wonder, like, what's the difference there? Like, those two are the most well known, and the others have certain properties that you might be interested in. Maybe not with regard to the search engine project. That is the data structure that you should implement. It's called an inverted index. In assignment 3, a lot of text, but let's go through it one more time. So first there was an interface, and we are going to talk about interfaces in a few minutes, because last week I thought, you know what an interface is, you did it in your introduction to programming class. I talked to Troels and he said, he did it more in an informal way, and then so I guess we have to go back to the drawing board and talk about interfaces a little bit. And so you should write an interface that is called index, and that one has 2 methods, and we'll do some live coding on what this means here. And then when you have the interface, you should provide some implementations, the simple index and the inverted index, with certain properties. Okay, and we'll actually do the simple index because this is a simple task where everything that is in the way of solving this for you might be you're not used to what this language means. So we do it together. But you have to do the inverted index yourself. And then then you should do an experiment. We talk about benchmarking today. And you should write documentation. That's what we did last week. That was the assignment. Okay. And there were some handouts, and I think also not only the handouts, but the discussion last week, like during the exercise session, was mostly about what is it that we have to implement. There's all this text, but I have no idea where to start. Yeah, so we should talk a little bit about where to start for you. And then there were confusing points. What is an interface? What is a class? Why do I have to implement 3 of them? How do I implement the simple one? It's called simple, but I don't know what's going on. What should the build and lookup method do? Yeah. Let's talk about that. Okay. Why do we have 3 indexes? Well, the index is the core functionality of the search engine. For now, it seems a bit stupid because you already have a solution for an index that were in the prototype. But there are many different ways to implement an index. And what I tell you, like there's this inverted index, there are many others. Yeah, and it's you can also, as an extension, work on other indexes if you want. But there is the core functionality, given a query word, what is the list of websites? That's the search engine. Okay, and so there are many different ways to implement it. Let's say you want to use the fastest. Yeah, for this you have to find out what is the fastest among all these 3 possibilities that you have to do. And for this you have to produce a little benchmark here. There's one group that started doing a GUI for people to choose the index implementation. Nice idea, but it's really not necessary. Like you don't care, you don't want to say google.dk and then you want, oh hi, I'm Google, what is the index that you want to use for your search today? So yeah, you choose for the user the best index for the task at hand. Okay. What is an interface? The index interface that I want you to do looks exactly like this. We do it in live coding, but and with some documentation as well. But it's this Java code that lives in an index.java, which says this is the interface. And what you see is, first of all, it almost looks like a class, but there is no class keyword. It doesn't say public class index, it says public interface index. Okay, so when you talk about an interface, you replace class with the keyword interface. What's also strange maybe about when you think about it as a class, and for a long, long time, it has been a class in Java. So this interface, that there are interfaces was a design choice from a certain version of Java, because it turned out that this is necessary to make have a clean separation. Separation of what? That's the question. But first of all, there is no constructor there. So an interface doesn't have a constructor. There are no instance fields. There are no member variables. There are no arrays there. There can be, but they are not on an instance level, but on a class level, and then you have to use static and final. You won't need that for, you shouldn't say yes, but okay. All the methods that you see in interface are public. So what you see that is missing is the public keyword. So usually you have a public void build method. In an interface, everything is public. If you would write public, nobody would complain on the Java side, but IntelliJ would tell you that's not necessary here. Everything is public. You can just omit that. Okay. But what the interface does is it separates the functionality, what is provided by the interface, from the implementation. So what it says is, what is an index? An index is something that has two methods. It has a build method, given a list of websites over here. It knows how to build the index from this list of websites. That should be written in the documentation. We shall do that. And it has a second method called a lookup. And that one is provide a query string, and it returns a list of websites. List of websites should be the list of websites that contain this one query word. Okay, and what you have is, like, that's what an index is. It knows how to build it. It knows that it has to be built from a list of websites, and it knows that it is there to look up query words, yeah, and give a string. And that's all there is in the interface. It doesn't say anything about how this goal is achieved. It doesn't say anything about how to build the index, how to look up, how this lookup method should work. It only says that's the functionality of an index. Yeah, everything that calls itself an index should provide these two methods, yeah, and should implement them. And the implementation is somewhere else. Okay? And in the actual code, you will always use the interface type instead of the actual implementation. And that's what we did in the search engine prototype as well. Because we always said, like, there is a list of websites. For example, there is a list of websites. And there is a list of websites over there. We never said that must be an array list or that must be a linked list. Because actually, maybe we are not sure about what the actual implementation should be. If it's more suitable for the index to have a linked list here or an array list. So we always had this in mind, that we provide the interface. All we want is a list. And at one point in time in the code, let's look at the code. Where was it? In the file helper. In the file helper we said, well, this list of websites, that's actually an array list. You change this one line and your whole search engine will be running on a new version of this list, yeah, which might be more efficient for your task. Yeah, but what we did is we said we need a list functionality. We don't care at all about how it's implemented. And only at one point we say it's an array list that we want. Okay, and that's a deliberate choice, and that's what you always do. You keep it as general as possible to make it as easy as possible to switch them. What we want to do with the index is we want to say there are three different indexes. There is the simple index, there is the inverted index using a hash map, the inverted index using a tree map. You could do that on your own. You say public class inverted index, there you go. Public class simple index, there you go. But it wouldn't have any connection. It wouldn't say that's an index. By saying, like, by connecting it with such an interface, you say both of them are an index. Yeah, you can use if you want an index, that's all you need. And I give you these choices. Let's implement an interface. So you have an interface, and what we do down here is we implement the interface. And what we have to do there, we say public class dummy index. Now that's a class. It implements the index. If you would write this part and leave everything out, then IntelliJ would complain and say you implement the index, but there are no methods. There are two methods up there in the interface, you don't implement them. So that's the dummy index. It does nothing. It's a dummy implementation of the interface. All it does, it says public void build, and you see the implementation is empty. It doesn't know how to build it. Basically, it does nothing. And for the lookup function, it provides the very nice return null that says, oh, this word is not found, or there are no websites connected. But that's how you implement an interface. You have the interface there, You implement it by providing a class, and you have to implement both methods. So you have to provide actual implementations. Whereas in the interface up there, we don't see the implementation. It doesn't go in there. And then how do you use it? The search engine only wants to use an index, and that's down there. So you can say something like index IDX equals new dummy index. Like you said, list blah blah equals new array list. Okay? So it's the general type, the interface here. And then all you do is work with the index, and you only say once this is going to be the dummy index or the simple index or whatever. That's an interface. It's used, and we use it in this way. We use it to say, we specify what an index should be. This is the functionality, 2 methods. This is what it should do. And we implement it in different ways. Okay. Let's try to do this together with the 2 main parts that we have, the first 2 tasks here in assignment 3. Write an interface index that specifies a build method and a lookup method. Write a class simple index that implements index as you have seen it in the prototype. Let's do this together in IntelliJ. So first of all, let's start with adding the interface. So we do a new Java class, and what kind of class is it? It's an interface. Let's do it, and we call it index. Okay, or it gives us something, and we public interface index. And basically what you have to do is, like, you see the documentation, like the requirements from the, where is it? From the description here. Write an interface that specifies a method build that preprocesses a list of website objects. What you at some point should be able to do is you read this natural language and you say, okay, I need a method build. Apparently it doesn't have a return type, doesn't say anything about return here. It preprocesses a list of website objects. So what it does is it gets a list of website objects here. Okay, it complains that it doesn't know list, so we import list here. Next, there should be a method lookup that returns a list of website objects matching a query provided as its input. That should tell you, well, the return type is a list of websites. It's called lookup, and it gets a query string.
Can I ask a question?
Sure.
If you make the document, for instance, in the terminal, there's no difference between an interface and a normal class.
That's true. Yeah,
so
there was
just the color here.
That's
the
true.
Color. Okay.
So here you see that, so IntelliJ knows that that's an index and that's a class. If you look at the files, the first one is this one is filehelper.java, that one is index.java. There's no difference whatsoever. There used to be, long time ago, but that's basically nobody used it anymore because everybody uses IDEs. They said if you write an interface, you have to prefix a capital I. So like 8 years ago, I should have called the index I index. Okay? To make sure like everybody knows that's an interface because it has a capital I.
In the title.
In the file name, basically. But also in the title. It would also have to say public interface I index. Yeah, and then the implementation would always be a index impl implementation. But I think people still use it sometimes, but not many do it. Yeah, there's still some books that refer to it. What you can also see, like the index, it doesn't tell you anything about what it does here on the interface level. So we should add some documentation for this as well. Yeah, what is an index? The index data structure provides a way to build an index from a list of websites. It allows to look up what do we say? It allows to look up the websites that are or that contain a query word. That's what an index data structure should be. Let's say I'm the author here for now. More important is like what are the method descriptions here. So again, Java documentation. So the build method, it gets a list of website sites, and that is the list of websites that should be, let's call it indexed. Yeah, and the build method processes a list of websites into the index data structure. Okay, and then there is the lookup method, and the lookup method is given a query string, returns all websites, or returns a list of all websites that contain the query word. That contain the query. The query returns the list of websites that contains the query word. That's the documentation of an index. And now you see there is no implementation whatsoever, but it specifies like if you want to do an index, that's what I wish for. Yeah, I do wonder a little bit why all of you try to copy that, but so I mean, of course, I also put the code on GitHub. That is the index. It doesn't say anything about how the goal is achieved. It says that's what I want. Yeah, I want to have a build method. It gets a list of websites, and that should then be processed into the index data structure, like the simple index or inverted index. And there is the lookup method that gives a query, and it should return a list of websites and it says something about what should this list of websites contain. Well, it should contain all the websites that contain the query word. So it specifies the functionality. It doesn't say anything about how this is achieved. Questions? Okay, that's the interface. Let's implement the interface with a simple index. Okay, and the simple index. Yes.
One question.
Yeah.
Why does it say override when you declare the method or define the method in the interface? When you are about to declare the method in the class, it says override.
Yes.
What does that mean?
Let's see that. We are going to. So the question is about a override annotation, and we'll see this annotation in a second. How do you implement the interface? There's different ways. The easiest in IntelliJ, you go to the index and you use the shortcut that you also use for autocorrection. For me, it's this alt and return to see like what are the choices here, and you see you can implement the interface down here. You click it, and it actually says like call it index implementation. We call it simple index here. Okay, and it says, well, there are these two methods. Do you want to implement them? We want to implement them. We also want to insert the override annotation, and let's say we want to copy the Java documentation here as well. What IntelliJ does for us, it provides everything that we need. So it says now we want to implement a simple index that implements this index interface, and you know implementing means that you actually have to provide the implementation. And the default implementation that IntelliJ gives you is empty build method, and the lookup method returns null. It has to return a list of websites, and the default one is you return null. Okay, that's the implementation, like the dummy implementation, and now we have to give meaning to that. And what we want to copy is what is already happening in the search engine. So there is an index hidden here in the search engine, because we get a query word here, and we go through all the websites, and we check for each website, does it contain the query word, and if it does, then it says query word is found. So these two lines here, this for and this if line, that's basically the logic of the simple index. Yeah, the build method is you have to store the list of websites, The lookup method is go through all the websites, iterate through them, check if the word is contained on the website. If so, well, then you found a website that contains the query word. That's the logic of the simple index. Okay? All we have to do is basically we have to copy this code over to our simple index. So the build method gets the list of websites and we just have to store it. So that means we have to that means we need some way of storing these websites in the simple index. The list of websites stored in the index. Okay, and then all the build method does, and that is pretty simple in this case for the simple index, is we store this list of websites. What did I do here? Like that. That's the build method. There's nothing to it. And then the lookup method, we go, so what we want to do eventually is we want to return all the websites that match the, or that contain the query word. So let's store this, make a new result list. Okay. And again, I say, I don't care, I mean, it's a list of websites here, so I also say it's a list of websites. But for now, let's use the array list as a way to store these list of websites. And eventually I want to return. And in here is missing the logic. Like, how do I find the websites that contain this query word? And the logic is already provided in the search engine in those two lines. Okay, so let's just copy them. So we go through all the websites. If the word contains, if the website contains the query word, then we should add this website to the result list. Okay, something's missing. There we go. There we go. That is the simple index. Build method just store the list of websites. Lookup method go through all the websites that we know. Check for each website. Does it contain the word? And if so, add it to the result list. Then return the result list. Yeah, and that's basically what we should have done here. Given a query string, return a list of websites that contain the query. That's how a simple index does this. Cool. Now we have to add some logic to the search engine. So now the search engine should work with the index. So let's say we need this index. Let's call it IDX. And for now we know how to build a simple index. From the file helper we pass the files. So we can then build the index from this list of websites. And of course we know building the index doesn't make much sense here. It's only like saying that's the list of websites, like copying over this reference. And then our query logic is for each query word, get the list. We want to know what are the websites that contain the query.
Can I ask you a question?
Yes.
When you declare the new simple index and
yes.
you call it IDX,
yeah.
Why do you, on the left side of the, what do you call this?
Assignment?
Of the assignment?
Yeah.
You state the name of the interface and not, you don't, why do you write index?
Okay, let's go back to that once I finish this part. Yeah, that's the most important question. Why do I write index here? Okay. So I build the index. This is here in this loop we get our query words. So what we want to do is we want to query the index for this line. And then we go through all the websites, through website result. We do it like this. Yeah. Something is a bit out of place. That is the search engine logic using an index. Yeah, you specify that it can use an index. You build the index from the list of websites. And then for each query that the user inputs, you look up the query word, you go through all the results and print out queries found on. That's the logic here. Let's check if it works, and then let's go back to the question, why is it called index there? Welcome. Let's see. I think I have this small. So it's still, I mean, nothing changed. Yeah, we added a lot of code, but nothing changed. Like the basic behavior is the same. You enter Denmark, and Denmark is found on these 4 websites. What was it? United was another thing on United States, and so on. That's the simple index. But now your search engine knows something about that is that it can use that it has an index data structure. Here, of course, I could also write simple index. Yeah, in the same way as I could say, I don't know. I mean, okay, I can't say that. Yeah, I could say something like array list here. That would be, but that would need some conversion because the file-helper.parse file returns a list of websites. Although it's an array list, it doesn't. I mean, Java doesn't know that. Yeah, to begin with. But again, this is just for keeping it as general as possible. If you were to change your simple index to an inverted index, all you need to do is you take simple array and you add inverted here, like this, and it would work out of the box. If you always want to say like there's an index here, then you would have to change many different lines. Especially at some point, the index is going to be passed over to other things. Like there is going, in the next assignment 4, there is going to be a query engine, and that one uses the index a lot. So you pass over the index, and the query engine doesn't care at all about whether it's a simple index, an inverted index, or everything is going to work automatically because they implement the indices, an index correctly. Yeah? It's like one line of line of code changed. Changes the whole behavior. And you don't know yet, is it the simple index or the inverted index that is fastest? Yeah, so it's basically a rule of thumb that on the right-hand side of the assignment you always provide the most general type, because there are no disadvantages to that. Providing the more specialized type there makes it more difficult to change the implementation. It also tells like maybe for most of you that's nothing that you understand right now, but it's also when you wrote a lot of code and you see like to the left-hand side you see a very specialized variable or assignment. Like you would see simple index here, and you know that there is the index there. That would be very strange. Then you would wonder, why did he look for the simple index? Then the first thing I would do is I go into the simple index and look through the methods and see, is there a method that is not provided by the interface, but that you really want to use? And here it isn't. And then I would be a bit lost, like, why did you do that in the first place? Yeah. I mean, everything still works when you would do, write simple index to the left. But experienced people would say would think of it as being something very strange. But there are no disadvantages provided or associated with providing the interface type there. Okay. Any other questions? So that is the first 2 parts here of this assignment. 3. Yeah, just to get you going. Yeah.
In the original search engine, there was at the end of the code, there was something to see if it was not in any.
Yes.
Is it still there? Or?
You should still provide a logic. So you have to change that part a little bit. And hopefully it's not that tricky. Yeah, that's right. I mean, we work with the basic prototype, and you know that there was also this when there is no query, so no website, and it should output something like no website contains the query word. You have to adapt that a little bit to this new logic. Okay. Any other questions? Yeah. So the interface, I mean, it only says that is the functionality that I want. And then you provide all these implementations. Okay. Cool. Then the next thing that you need to do for the index is benchmarking. So hopefully, like end of this week, end of next week, you implemented all these. You implemented the inverted index as well. And okay. Let's first further advice. Yeah. What you shouldn't do is please don't make output in the index. Yeah. What we saw right now is that I took the search engine and all the output code is left in the search engine. And the index only uses lists, no output at all. Yeah. Please keep it like this. Otherwise, it's going to be very difficult to work on the further assignments. You should wonder a little bit like what happens when the index does not contain the query word. And in my solution, it's already like this, that it returns an empty array list or an empty list in general. Yeah, you should keep that. Yeah, it's like you can also return null there. And then you have a lot of null checks in your code. Yeah, like especially like when you look at the final product, these 6 assignments, there are like 10 places where you did a null check because of this one change that you did there. What is not okay at the end, you say I solved assignment 3 and I look at your assignment 3 and you say, well, I have the inverted index hash map and I have the inverted index tree map. And what I did is I took inverted index hash map, took these 50 lines of code, yeah, all the class. I copied it over, called it inverted index hash map, and changed one line. I changed the hash map to a tree map. That's not okay. Yeah, you should find a better solution for doing this. Yeah, it's a bit for many of you. That's a bit looking into the future. Like how do I want to do this? If this is the way you want to do it, please don't. Yeah, really don't. There is a principle. DIY. Don't repeat yourself. That's like the most important principle of software engineering. Whenever you think like, oh, I have it over there. Let's copy and paste it over there. That's the worst idea you'll have, like in your life, yeah? Because at one point you will see, oh, okay, maybe not in your life, but with regard to the project. But there is going to be a point where you think of, oh, I need to change a line there. And then you ask, like, where did I copy it? Ah, it's over there as well, and it's over there. I have to change the line, and down there as well. Yeah, please don't. Never repeat yourself. If you think like copy and paste is the solution, it's never the solution to a problem. If you think your inverted index is going to be difficult, please talk to me. Yeah, there's something that where you might think a bit too complicated about this issue. Yeah, the inverted index is something that once you have done it, the lookup method is like 1 line of code. The build method, maybe 10 lines of code. Yeah, and you can explain like in the at the end in the oral examination, I will ask many of you like, how does the inverted index, how does the build method look like? That's something that you can explain to me in 20 seconds, like your whole code there, because it should be very simple. Yeah, and to avoid confusion here, if you think it's very complicated, then you're probably doing something wrong, like I do now. Okay. Just some advice when you work on this assignment. Keep that in mind. Yeah. Don't mix up responsibilities. That's something that I said as well. Never start optimizing now at this part. Yeah, you think like it's very smart to use something else as a data structure. At some point, for example, in the website object, you see a list there of strings. Shouldn't it be a set of strings to make it a bit more, to make this one check a bit more efficient? It might be at the very end, but you don't know that yet. Yeah, you have to see all the assignments because it could be that you will revert back. Yeah, so when you feel like I can do it much better, you might be right, but you should wait for all the assignments. Okay, benchmarking. How do you eventually decide for the index that you want to use? Well, what is benchmarking? Or you will write a benchmark and you do benchmarking. Oh, that's very annoying. Might be this little tape here. Okay, let's see. So what is benchmarking? Benchmarking refers to running a program, well, in order to reason about the relative performance. Okay, so what you have is a simple index, and you want to compare it to the inverted index. You might not be very interested. You might not be very interested in the actual difference in running time. Oh, that's not me at all. You might not be interested in the actual difference in running time, but you are interested in these. Let's see. This is going to happen. Let's see. Okay. What you want to do is you have a method. You have several implementations of a method. You want to say that is the faster one. Yeah, that's what I want to use in my search engine. And that's what we want to do. We want to assess the relative difference in running time. How long does a query take with the simple index compared to the inverted index? And then inverted index hash map against inverted index tree map. Okay. And what all you need to do is you have to measure running times. Yeah, and we'll talk about how to measure running times. And you have to design an experiment, and I will tell you a little bit how to design this experiment for measuring running time, because it's not like super simple how to do it. Yeah, and you should take some precautions there. Okay, and the experiment is going to be a different file. It's like benchmark.java, and that one says like which methods should be called, which input parameters should there be, and then it says I measure this running time, like that, and that. Okay. And the goal is always to compare different implementations. And for us, that's different index data structures. Measuring running time is super simple. What you need to do is you take a timestamp over here before the code runs that you want to measure. And there are I think there are two ways in standard Java how to do this. There's current millitimes, which gives you millisecond timestamps, and there is nanotime, which gives you a nanosecond timestamp. Since someday, no, I actually don't know how Java does it. Yeah, it's a timestamp. Yeah, but you're never interested in the timestamp. What you're interested in is what was the time before, what was the time after. Like those two calls give you time before and time after. The difference is the elapsed running time. Yeah, that's how long it took. And here it is in nanoseconds. So those numbers are going to be pretty large. And you should divide, for example, by 1 million. Then you go from nano to milliseconds. That is much more suitable for the output. Okay, and just to give you an idea how it looks in code. So maybe first, let's go here to add these indices. Okay, you can't see anything. That's the wrong way. Okay, just to make it proper, edit indexes, edit index implementation. Implementation to prototype. Okay, so you should be able to see that on GitHub. And then let's see. What I want to do is I want to output how long it took to pre-process the data set, just to tell you like how does this work. So we have this index here, and we take a timestamp. Let's call it T1, and it's system dot, and use. It's always. I mean, I really like IntelliJ for its suggestions. Do you mean nanotime or current time millis here? I mean, there are 1,000 system methods, but it says like if to your left hand it says long T1, maybe the T is time. Maybe you mean time, and I do mean that. Yeah, and it's a bit annoying. You feel a bit stupid when you think you're so predictable here. Long T2 is. So then we pre-process the data set. We read the file and we build the index. and we want this as well. And then we can have a output like processing the data set and building the index. What? Took, and then T2 means minus T1. That's the difference in nanoseconds divided by 10 to the 6. That should give it, put it down to milliseconds. Milliseconds. Like this. And if we rerun it, we get this output. So processing the dataset and building the index took 2.3 milliseconds, very fast, but it's also a web data set of 6 websites. Yeah, very small.
Question.
Yeah.
But if you want the time in milliseconds, why use the nanotime? Why not just the milli?
You should try it. Yeah, it might work, but it's like you get the timestamp in milliseconds and then you get another timestamp in milliseconds. It would either tell you 2 or 3. It could actually tell you 1.
So it's because of accuracy.
Yeah, it's because of accuracy. Okay, and especially like your query times, they might be in the, so this might be 0 point something milliseconds for a small query, especially if you use a map data structure then. And this will tell you 0 milliseconds, and that's all there is to say. Yeah?
T2 minus T1
Yeah.
divided by what?
By 10 to the 6. 1 million. So that's an easy way to write 10 to the 6.
So it's 10e6.
It's 10e6. That's how you write it. Yeah. So there you, so it's 10 and the exponent should be 6. It's 10 to the 6. Okay. That's how you measure running time. Yeah. And it's just easier than writing 6 zeros because then I always have to count. Yeah, and I always make mistakes when I start counting, so this is far easier. Okay, not much time to the break. How should you then, so that was indexing or measuring the time for preprocessing. You should adapt that for your query time to say the query took that long. I hope you can do that. And then you should do a small experiment. You shouldn't like run your search engine by hand to see like this is the fastest one. I run it 10 times manually and notice this is the fastest one. You should write a small experiment. And you should, my suggestion is try the following. You have a small set of query words, let's say Copenhagen, Japan, off university, add some more. You have some data sets, the tiny data set, small data set, medium data set. There's also a large data set. And there are index implementations. Simple index, the inverted index with hash map, inverted index with tree map. And you should write a benchmark. For example, like benchmark the index data structures, because later you might want to benchmark other data structures as well. And that one should have only one main method. And the main method should look a little bit like this. So you have a data set that you want to benchmark and an index that you want to benchmark. That is somewhere up here. But then the actual benchmark could look like pass the file, build the index, take the start time, and that's the actual query time. Like go through all the query words, look them up, and say what is the start time and what is the end time. Yeah, what is start time, what is the elapsed time. This is how long the queries took, all the queries, answering all the queries. And then you can just print it out. Okay. You might notice something strange here. There's a lot of boilerplate code around that. There is like a found websites, and I always add like the found websites. Like how many did I find? I mean, that's not really important for the experiment. And I also print that out, like websites found is this number. That does not at all belong to the benchmark. Does anyone have an idea about why this is there? I mean, you can verify the result that it worked correctly like that. But it's also, yeah.
Is it to verify that the time difference isn't because it's looking or found more websites for certain order?
Nah, I mean, you could do that. Yeah, you could do that. I think that's one of the one of the I also say that in the end that you could divide by the number of query words or by the result list to get like an average query time, something like this. But you can try it without, and then I tell you, you should run it at first, you should run it 1,000 times. The thing is that Java is very smart. It always, like, when you run the first few iterations of a loop, it looks like, can I optimize something here? And if you only have like start time, elapsed time, and you don't do anything, I mean, you look up the word and you throw it away, and you never do something with the result, then Java is going to say, oh, you do stupid code there, you don't use it for anything, I'm very smart now, I'm just going to delete these lines here. They are never executed. You should check that out yourself. Like, remove everything and wonder eventually why all of these index methods are so fast. They all take like 0 nanoseconds. It's like super fast index methods because Java decides to just remove the code. If it's not used, it's removed. And that's very smart of Java to do in general, but it's very annoying if you want to run a benchmark. Okay, that's a suggestion. You can do it however you want, but that's an example of a benchmark, how you can run this. And there are some remarks. It's very difficult to do these things in Java because of, especially of these issues. And there's, I have a paper here, and it's by an ITU professor, Peter Sestoft. And you might specialize in something with programming languages, and he'll tell you a lot more about these issues. And then you can also output the average query time. Very nice. Right, and what happens if you remove default websites? I told you, you can check it yourself. Okay, and your third assignment, that is the benchmarking part here. Yeah, try to do it like this. Benchmarking advice, read it yourself. Benchmarking advice. One important thing, you have this code that I showed you, and usually if you want to do it really properly, you don't have to in this course here, but if you want to do it really properly, then you have to do something that is called warming up the Java virtual machine, and that is, you take the lookup code and you don't measure running time at all. You just run the same thing 1,000 times. That tells Java, well, that's how it looks. Please start your optimizations if you want. And then you do some final iterations to measure the actual running time. Okay, so there is some boilerplate, just warming it up, just telling Java this is how it looks. And then you do the actual running time measure. If you implement, or if you do your benchmark, you'll notice that no matter if you warm up or not, the result is going to be very clear in this index is the fastest. Let's say the simple index, that's the fastest. All your work on the inverted index, but the simple index, that's how life is. So the difference and the relative difference is going to be different at all from the beginning without doing these warm-up repetitions. But doing them, like if you measure query time up here, or after 1,000 repetitions here, Java will have figured out much better how to run this query, what your code means. So this is going to be much quicker than what you have down up here. Okay, but that's internals. But you'll notice, and I'd like to warn you, like, this is what you could see. Questions? Here, this part. Yeah.
I'm not sure how to implement that.
You don't have to now. I mean, write your benchmark code. Yeah, I mean, this thing comes first, like writing the actual benchmark. And then you have to put some things around that, next. But I mean, if you are certain how to do this, then we can talk about how to do that. Okay? Cool. And unit testing for you is a way to basically check, is what I did correct? And let's talk about that. So what is testing? We are debugging. Testing is the process of executing a program with a certain intent, and the intent is you want to find errors. Like if you did really well, you found a lot of errors. That's a bit destructive for your coworkers that did this code, but it's what you want to do is you want to find errors, and you want to find as many of them as possible. If you're a really good tester, then you're good at finding errors. And the nice thing for a tester is you don't want to find the reason for an error. You just tell them, there it is. Yeah, it crashed. It shouldn't crash. Do something. Okay, that's testing. And we talked about like finding an error with debugging in the last lecture. Okay, and there is this constructive thinking that usually all of you have in the beginning. It's like you wrote a piece of code, and what you do is like very constructively you test to pass. You know how it works. Like you only test the obvious things that you know they already work. Yeah, and for that reason, it's also the same for me. If I write code, I should write tests for that. Then it's usually I do obvious tests. Yeah, it's like, and usually it's not a good idea to test your own code. Yeah, because I mean you did it. You're smart. Of course it's correct. Yeah, and look at the test. It says it's correct. Okay, and usually in a big software company, you have different branches. Like you have the software developers and you have the testers. And I think here in Denmark, I worked in Sweden once, and there it was, they were paid the same. Like a software developer and a software tester had the same pay. And the software tester, I mean, he didn't do productive work. The only thing he did is like told you, okay, you did something yesterday, everything broke. There you go. But I like that. I mean, I like the destructive thinking. You really want to test to fail. You want to find errors in the program. And I think it's quite motivational. Yeah, somebody gives you a piece of code and says like, that's the solution. And you'd like to tell him, no, that wasn't good enough. Yeah, it's quite motivational. You always have to think like, how can I break this person's code? So that's what you want to do. Yeah, you want to you have someone else test your code, and you really want to try everything to break it. It's really important. Where was this? Where did this slide come from? Okay, but you have bugs in your program, and the question is like, there was a study once, like how much does it cost to find a bug at a certain period of time? Like you make mistakes. I mean, we make mistakes all the time in every single step of the design and development of software. Yeah, there might be a bug in the specification. That's pretty easy. Like if there is a bug in the project description here, you tell me, I fix it. Not big of a deal, not a big deal, let's say. Yeah. Same goes for design. If there is some bug in code, then the software developer starts and does all its debugging, and maybe it takes a long time, and that costs maybe a lot of money. Not only because the software developer can't do other stuff, but also the whole production is delayed. Okay. But it's still like these things are pretty cheap. But if something goes wrong in the testing, and that's the testing that we'll later talk about, like the final testing before you ship your product, like before your what is it? I think 21st of December. 20th of December, you see, well, assignment 4 and 5 don't work at all. Yeah, you have to ship. 21st of December, that's the hand-in date. Yeah, it's going to be hard. It's going to be a hard night, maybe for you. Yeah, it's going to be very difficult. If you release it, it's annoying how much things cost. Yeah, when I worked at this company in Sweden, we released the product. It was very successful, and then Apple came and said, "Well, how do you do this one thing? Like, how do you?" And it was Opera. Maybe many of you might know, or some of you might still know Opera as a web browser, and Opera, and I was in charge of something there, and it was very nice, and it worked beautifully. But and I developed it according to the specification. But 1 year after that, lawyers from Apple came and said, this feature, how did you implement that? Like, well, we tested it, and it looks pretty much like something we have a patent on. Yeah, and it's annoying. It's an annoying world. Like the patent is, if somebody starts typing something in the address bar, what should you? Or like at that time, it wasn't like now where Google says, "Is that what you mean? What you meant?" But at that time it was like maybe you want to give back, or you want to suggest the first result that matches whatever was written there best and was previously visited by the user. Yeah, that's what we did, and that's what we are not allowed to do without paying a lot of money to Apple. Yeah, and I think, I don't know, I'm not working there anymore, but so I don't know how they settled. I guess they settled something, but that was really annoying. Yeah, because you did the obvious thing there, and you just forgot, like in this phase, somebody wrote like, if you type something there, that's what you should do, and they forgot to check whether you have to pay money for that idea. Okay, that was very, very annoying. Yeah. Why do you test software? I mean, there are a lot of software errors. You might have heard this from last year, this Tesla Autopilot, which thought, well, that is a nice sign, but it was a truck. So that happened. And then lives are at stake, and that's not nice. So, not nice, my English. So you test software, and nowadays, software development is quite critical. Yeah, a lot of products we do have real life impact. And I mean, after 2 years, you might start in a company and you design things that have really real life impact. If somebody not goes according to the specification and fails, there might be lives at stake. Yeah, and so you really want to make sure that what you did is correct. Okay, and there is a list of software bugs, and it's very annoying to see what happened. It's the most annoying thing is like to then see why did that happen, because usually it was like one line of code where somebody just didn't think like of how to do things correctly. I advise you like go through this list of software bugs and see like what tiny mistakes had a large impact. So we want to test the product and see and be destructive. We want to see that it fails. And there are many different versions of testing, and a lot of them will be discussed in your software engineering and qualities course, but that will be beginning of November, and that will be on a different level than what we do today. So in general, there are many different perspectives on testing. There's static testing. And static testing means you see the code and you just go through this code, or you let somebody else go through the code. Never you click on run. Yeah, you just go through the code and you do code reviews, walkthroughs, and inspection. We talk about this in 2 weeks as well, how you do these things. And there's dynamic, you execute the program to find errors. Okay, so that's one dimension that it can have. There's black box versus white box testing. Black box means you don't look at the actual source code, but you rather look at the intent. And the intent is, for example, you get it from the project description, or you get it from the software documentation that you saw. That is black box testing. So you don't know anything about the internal implementation, but you know that that's how it should behave. Like if that's the index lookup method, and that's the list of websites, that's how it should behave. I don't care at all about the implementation, but that's how it should behave. And there's white box, and there you look at the source code. You look at the source code, you look what the programmer did, and you try to test like if this is correct, if this works correctly. Okay, this is another dimension, and the last dimension we are going to talk about is unit testing versus systematic or system testing. With unit testing, you test very small parts, very small units of the program. With a system test, you test the whole program. And basically software testers at companies, they usually do that level. Yeah, they take the program, boot it up, and click everywhere and try to make sure that everything is still running. Okay, that's the system test. Unit test, smallest units of your program are tested. And we are going to write some code for that as well. And we focus on these unit tests. Not at all black box or white box. We can try both. We are going to do, I think we're going to do black box today. And what you do is you test single methods. That's the level that you test. Like you have your method, it's called lookup. You know that's the output, that's the input, and you test whether the method works as specified. And it's a really nice, so unit tests are a very good tool to find errors in your program. And I think it started like 20 years ago, and if you go to large software project nowadays, there's usually more code for unit tests than for the actual product. Yeah. And what are goals here? I like to have it, so I write it all the time as well, and it gives you quite some confidence that your program will work as expected. Yeah, of course you have this test to pass behavior a little bit if you wrote it yourself, but it's already like you do something, and that's maybe what you'll also experience. for assignment 3, you think this should work, but you really want to know, and then a unit test is an easy way of verification. Okay. And more importantly, maybe you know that at this point in time it worked, and then you change the project a little bit. What you want to know is, when you make changes later, does it still work? Yeah, it's called that's usually called regression testing. You have your unit tests, and you see that at some point somebody committed something, and then your unit tests fail out of the sudden. Then you can pinpoint down, like this piece of code there. This produced an error. And that's very good to know. Yeah, and a regression test is then usually, you see what changed and you add unit tests to make sure this never happens again. Okay, we do unit testing. What testing can never achieve is, so it can never verify that your solution is correct. I think I don't know, in your master degree, if you're going to learn that in general, like software testing is like saying that this method does the thing you want it to do. Is very, very difficult, because many things can happen. Yeah, many things usually outside of your Java virtual machine could have an impact there. So this is usually something that's very, very difficult. So it never verifies that your solution is correct. Yeah, but at least it tells you for the things that you have tested, that seems to work. Yeah, and you could miss a test, or something else could happen. Okay, and what we do, for example, for assignment 2, you say there is this file helper and you did some changes and now it works, and we do some unit tests that we run in the background. That's why all your GitHub repositories are named in a certain canonical way, and that's why I produce the prototype, so you don't diverge too much from how it should be set up. So in the background, I always have some test cases, and I'll check, like, does your code pass these test cases? And we'll actually write some test cases our own, like in 20 minutes. That's not too different from what I test for assignment 2. Okay, and well, if a unit test fails in your project, I'm pretty sure that there is an error. Yeah, you did something wrong. If not, or the TAs, they have a quick look. But the better the test is, the more convinced I am that your solution is already pretty correct. Okay, we still don't know how to write tests, but let's see in some more abstract things next. What do you test with a unit test? You test each of the methods. If you write a new method, you should test it. Some people say setter and getter methods, like these get title things, they are not tested. Yeah, but that's a personal opinion. I leave it up to you. And you should always test that the method works according to its documentation. There is the project specification that tells you the index lookup does this thing. There is the documentation that we wrote just a few minutes ago that says this is what the lookup method should do. And you should test in your unit test whether it does this or not. Okay, and it's very simple to write. Okay, and which inputs should you choose? I mean, abstractly, there are many, many inputs. The lookup method gets a string of queries. There are a lot of strings that it could get. Yeah, but although there might be infinitely many inputs, you can't test. I mean, you can't test all of them. So you have to check. You have to sort of choose certain samples. And there is some way how to choose certain samples next. And the most easiest thing is take some standard inputs and test extreme cases. Yeah, take the minimum or the maximum, take some invalid inputs, and test whether these things work. And these well-chosen standard cases. And there's usually this picture here, like if this is your space of inputs, yeah, and you choose such clusters, or one big cluster here, this is not a good input. Yeah. If you choose it like this, like only the extreme points, it's not a good input. Those are not good test cases, because you know it works good in extreme cases. You have no idea how it works in normal cases. Yeah. So it's meant as those are the normal cases in here, and it gets more extreme to the boundary. Should be some well-spread examples. Yeah, and there's some methodology behind that, but usually it's a bit of experience and practice, yeah, that goes into choosing these cases. Okay, and there is some advice that you can read later. There's one thing that I'd like to tell you, which is some kind of a proper way, abstractly, how to test inputs. And that is called equivalence partitioning. And I think you heard about equivalence partitions or relations, equivalence relations in your math course. And that's basically the application here in software development. It's called equivalence partitioning. And what you do is you divide your input. So this is your space of inputs. And you divide it into partitions. And how do you do that? Well, you say, there is a string that is the input parameter. And you say two strings, x and y, they are equivalent. I don't know if you use this relation here for equivalency. We say they are equivalent if we look at the method, and given x and given y, we go through the method and we see the exact same instructions are executed. Yeah? So you go through the method and you see on string x and on string y the exact same methods are invoked. Then we call them equivalent. And if you go back to the math, you have these infinitely many inputs, but they will tell you, well, all these inputs behave in the same way, they all they all execute the same path throughout the method, and you partition the input. Okay, that's a property of this equivalence relations. Okay, and then you are lucky because then you only have finite number of partitions, and the test cases are very easy because you choose one here, choose one here, choose one here. Yeah, you choose one of each class of this equivalence partition. And there is a for example, at Wikipedia, if you go to equivalence partitioning, they have this piece of code here. So that's a Java safe edition, int A, int B. And I guess Trolls told you about problems with these integer types in Java. It looks a bit strange. Why do you need a safe edition? So all you want to do is you want to do A plus B. And you see, well, on line 2 you do A plus B. And then at line C you want to return the C. But as you all know, there can be overflows. Yeah, some people call it underflows in your in these integers. Yeah, if you have A and B too large and you add them together, then all of a sudden the result is negative. That's called an overflow. Yeah, if both of them are negative and the result is positive and you added them, that's called an underflow. Okay, but so yeah, you have this method. And then you can wonder, like, how many partitions are there? So you have integer and integer, you have A and B. And the question is, how many equivalence classes are there? And the answer is that there are 3. And what you basically look at, and you have to think about one thing next. So all of the methods, no matter what A and B is, they start here. And then there are these 2 if statements. In one case, this if and this if, it's both not true. So the first thing for all the normal additions is this line is executed, the ifs don't happen, C is returned. That's one line through this program. And then there is the second one, there's C, and then this one is true. This one is returned. That would be the second equivalence class. The third one is, this one is not true, but this one is true. That's the third way to go to this program. And you might think there's a fourth one because you could go here, here, and here. This can never happen. But it could possibly be true that both of these ifs are fired here, or fire here, but this is not true. But there are these 3 ways through this program. Could be 4, but there are only 3. Equivalence partitioning means you look at this code, you look at these if-else branches, you look how the code can diverge and go through this whole method, and you say, with each way how this method can be invoked, you associate like a path, and at the end you want to test one case from each of these paths. Okay, so a good unit test here, whatever unit test is giving it a normal one, giving it one overflow, and giving it one underflow, and seeing whether it works accordingly. That is a way to reasonably choose test cases. Sometimes this is applicable, sometimes it's not applicable because it's too difficult. Yeah, and there are even other problems, such as, you know, this is how many paths there are through the program, but then in the method you have another method call, and you don't know anything about you. So let's say, so you have a method, you have this if here, and you call another function with some parameter here. In the unit test, I mean, the equivalence partitioning says there's one path, it takes the if, and that is something you have to test. You have to make one test case. But you don't know internally like what f does. Yeah, you don't know that. You don't know if on A and B, although they have the same execution order here, what happens in f is different. Then you hope that f is well tested as well. And you say, that's not my problem, that's the problem of whoever tested it. This is some theory. It's actually some kind of software development technique as well. So if I guess in it depends a little bit. Did you hear about test-driven development in your software engineering course already? No? Some people nodded. I guess, did you hear about test-driven development? Some people nodded. Did you hear about it in your software engineering qualities course? No, okay. It's one form of software development. It's a very special form. It's, I guess, my estimation is 30–40% of software companies. If they look for software developers, they ask you, they tell you it's not a requirement, but it would be nice if you already know TDD, test-driven development. And just to give you the idea, sometimes it's really nice, sometimes it looks a bit complicated. So what you have is you have test first development. And where it usually starts is you have the documentation, and first you write tests. This is how it should behave. Like on this, no matter how the method looks like, if this is the input, this should be the output. If this is the input, this should be the output, and so on. Okay? And what you have is you first do this development. And only if all the tests succeed. So you write enough code, and you write it to the point where all the tests are fail. All the tests pass. Okay? Somebody gave you tests, you did some coding, they all passed. That's nice. That's the first goal. And then there's the refactoring phase, yeah, where you refactor some code, you update failing tests, you correct regressions. But the idea is first testing, develop until all is done, then maybe somebody comes to you and says, well, we need some added functionality. Yeah, you refactor your code, you write your code so that, just a second. Right, okay. So you have to test. You have to test, and this is the one that specifies how should the code work. Yeah, this is the important distinction. Like here at the project, what we do is I tell you that's the requirement, and you do some coding, but there's no testing phase involved. Yeah, what I would do in test-driven development is that is the project description, and here are these test cases, and all I want you to do is to write enough code to have them succeed. Yeah, that your input, that your methods work according to the specification. Yeah, and if they do, you have this refactoring phase over there. Yeah, that is the point. That's what I described wrong. You have the refactoring phase. What do you do once you solved all these tests? Well, you go there and say, maybe I didn't find nice solutions. Yeah, and you do refactoring. Refactoring is something we talk about in 2 weeks as well. Yeah, where you take your code and you want to make it nicer. Yeah, easier to understand, nicer. Yeah, and you do these refactorings. Yeah, always with the idea that they should still pass the test codes. And once somebody else comes and says, well, this is some new specification here, then you get some new unit tests. You have to switch to this phase again, and you have to implement as long as these test cases succeed. Yeah, it is a bit strange. So test-driven development, a lot of people use that successfully. I think a lot of companies use it successfully nowadays, but usually they have some agile mix, some Scrum moved into there, where people don't stay in this refactoring phase, but rather do something else. They work on a different project. Okay. The most important thing is how do you write these tests? And that's what I want to do in the last, say, 12 minutes. And so how do you do tests? What I thought is the most applicable example is, let's write tests for the file helper. The file helper was done in a very easy way here. Yeah, and assignment 2 was fix some issues with the file helper. And so first of all, let's make some tests that are supposed to pass with the current code, and then make some tests where we see something is really wrong with this code. Let's see how this works. So first of all, we make a test. And in IntelliJ, you should first split up tests and source code, otherwise it gets a bit messed up. Where was this? So there should be a new directory, and we call it test. And it goes with the source. And usually you have to say in IntelliJ, there is this mark directory as. It might be that this is missing because it's already there. Just a second. To give you the same view that you will have as well, let's start with this. Then you have a new directory, you have to click it, and you have to say mark directory as. Test cases are in test. And for the file helper test, we actually need a file. And you usually split that up as well. So you say there is a new directory, you call it test resources. And you have to say, well, those are test resources. So all the files that we use for our tests, they go into this directory. Okay, that's the basic step. To make a test case, the easiest way is again to go use IntelliJ and just go to file helper, use your favorite command for these auto suggestions. And there you see the suggestion is to create a test. And we use JUnit 5. There are a lot of different tools for using it. And this is the most standard one. You will notice as well at some points you will see the output is really ugly. And that's why there are other tools. Yeah, but these other tools come with different ways of writing test cases. So I'd like to show you the most standard one. And that's JUnit, and we use JUnit 5. Your IntelliJ will complain. It doesn't know anything about JUnit 5, and you can just click on Fix. And you should use the IntelliJ version. Okay. It will already tell you what can it test for. We said unit tests. What you do is you test each method. The file helper has one method, pass file. So we will make one test for pass file. Okay, and that's how these test files look. You could do it on your own, but it's a bit more convenient to use IntelliJ to set these things up. And they go in this test directory. They have a canonical name, so you have a class file helper, and where the tests go is file helper test. What do we want to do? We want to pass this file, and you see there is this test annotation here, and the test annotation basically tells you, well, this method is a test. It tests a certain method, and this method is pass file. How do we test file helper? Let's first look at what file helper does. It gives you it assumes you give it a string, and it gives you back a list of websites. That's what we should test. Yeah, and there was a certain, here there is documentation missing for the file helper there, but there was a certain requirement, like this is how you pass files. So given this input file, this should be the output. That's something that you as a tester reads from the project description in this case. And then you make up files, and I made up 2 files here. So a very nice file. Yeah, that's my version of it after I implemented it. It starts with page, then title, then word 1, word 2, page, title, word 1, word 3. And maybe when I would give this code to somebody else, he would rather come up with something like this, which contains a lot of invalid things. So this was a valid entry. This is page, title, word, word. Fair enough. And down there, it's a valid entry. It's page, title, word, word. That's also according to specification. Here we have word 1, word 2, no page, no title. Here we have a page with a title, but no words. Here we have a page, no title, no words. Here we have a page, and the title is 2 words that are split, but there is no word coming here. So you as a tester, you read the project description, and you say, well, if you did it correctly, then you should be able to pass this file as well. Yeah, and the result should be this here is an entry in the database, and that one up here. Everything else has to be skipped. Okay, now that's the difference. Like, I would write this here as a test case, and hopefully it succeeds, and you would write this one as a test case, hoping that this one breaks the code. Let's just copy those files over. There are the test resources in here. Okay. How do you write code? It's also how do you write tests? It's also on the slides. I'm just going to tell you how you do it. First, we have to load something, and we have to actually look at what does parsefile do here. Let's use this. So we call filehelper.parsefile, and as a string we say in the test resources, we want this test file.txt. Okay, and now we have to check whether whatever file helper gives us back, the return type, this output, is what we expected it to do. Okay, and you assert it by using certain assert methods, and those methods are assert equals, it's assert true, and it's assert false. Okay, and now you have to find test cases. Now, how do we check whether the file helper correctly passed? Oh, where is it? Correctly passed this file. Okay, first we should check whether assert equals, and that is the actual behavior and what you expected it. So the actual behavior, let's look at sites and let's see how many websites are there loaded after reading this file. And what do we expect? We don't look at the code at all. So we do this kind of black box test. And we just look at it, and there are 2 pages here. So the answer is true. Yeah, and IntelliJ tells you that's the what? That's the actual. Oh, did this change? Just a second. Ah, I just need one check here. Is it like this? It doesn't change anything on the result. Yeah, okay. So it's expected and actual. So we say sites.size, we expect it to have 2. And then you run the test here. And you see a very different output. Oh, and it fails. Very nice. Why does it fail? The actual value is 0. Ah, I didn't find a file. How is it called?
It's resources, has an XPC.
Thank you. Thank you for waiting with that. Because nobody can listen to what I said, but it was rather waiting like when does he click on run this test? Okay. But so let's see. Okay. When you run unit tests, what you want to see is everything is green. What you really don't want to see is something red there. Everything is green, so it's true. The sites.size gives gives back this one. If we would run it again and we would falsely claim that there should be only one website, it says test failed. And that's a little bit the issue with this JUnit. The output looks really crappy. Yeah, so it's like the important thing is up here. It expected 1, but it got 2. And then it also tells you like, and this is how it came to this conclusion. It started at file helper and you have all these things. It's a bit ugly. Yeah. The important thing is what you see up here. Okay. But let's write a nice test here. So this one should be 2. And then let's just check the first, let's say the title of the first website. So now a method that just returns a list of 2 elements would pass this test. So this is not a good test yet. So we have to check a little bit more of the internals. Page 1 has title 1. So we expect that title 1 is the title of the first website and title 2 is the title of the second website. And here we assume something that should be written in the documentation. Because we think that, well, the first element of this list is the first website. Yeah, and the second website is the second element of this list. Okay? And that's what we assume here. It should be written in the documentation. We left the documentation out. But then let's do maybe assert true, that, assert true, that the first website contains as a word, let's check it, contains word 1. And it does not contain word 3. So we can assert that this should be false. Let's run it again. And everything is green. Yeah, so this parse file here worked pretty correctly. Yeah, from here. We can do some more checks. Let's keep it like this. To make a full check, you basically want to check all of these things, that they are correctly set. We don't have time for that yet. We also miss a certain method here to check for that. Because what we really want to check is whether in the website, this list of words is word 1, word 2, respectively word 1, word 3. Yeah, we can't really do this with our interface. So we might have to change the interface. But let's say that's good enough. Okay, this is a nice test. We looked at it and we tested to pass. Yeah, it's a very nice file, pretty clean.
Is it normal to make it this specialized? Like test for a specific
No.
file with those words?
This would be a normal test for input-output. Okay. Yeah, you would provide certain files and then you would really test for things like this. Usually you never have input-output, like real file reading and things like this. And then, I mean, then these test cases don't happen usually. Okay. There's parse file, and let's say that's a good file, parse good file. So another test case would be to now test a bad file. And the bad file was the one that contained some errors. Where are we? Test file with errors. And if I didn't make a mistake, then they are both equivalent in what they, yeah. So it's both page 1, page 2, and that one just has some added stuff in here. Okay, and if we run this test down here, so the first one ran, then we should notice some errors. Okay. So our unit test makes kind of sense because now it shows on a file that is incorrect. The file you provided, that whereas for such a file it works, once there's an error, things happen, and they shouldn't happen. And here the first thing, and it always goes down to the first error it noticed. And there are many errors here. But the first error is, you told me that you expect 2 websites in this file. Okay, this one. Well, I got 5. Yeah, so there's, I think this is the first one that we created, and this wasn't actually, how many are there? Okay, I think there could actually be 6 in here. It only created 5, but it clearly, like our file helper, the one we did in class, that one has an issue when the file is not according to its specification. And your assignment 2 was fix that behavior. Yeah. So when you run the test, I'm going to comment these things out. Yeah, pretend everything works accordingly, just to see all of these green things again here. Our test passed. Very nice. I'm going to add this to GitHub. You can integrate it into your project. If you think assignment 2 is correctly solved, this test here should run through the bad test. Okay. That's basically all there is. Choose test cases. That was a bit ad hoc here. We talk about more about it in 2 weeks when we talk about testing the inverted indices. There are some things that you might wonder when you test them. Yeah, and then we'll talk a little bit more about choosing the right candidates. But testing is, on a conceptual level, each method gets a test. Unit testing is, each method gets a unit test, maybe more of them. And all you do is you load, you check. So you run your method and you check with using assert equals, assert true, assert false, whether the result you got is what you expected. Okay? Questions to that? Yes? Could I create it again? Yeah. So let's say we want a website test. So for me, it's this magic shortcut that comes up. So it's Alt and Enter. You click on the class name, and you have, as it's a suggestion, create test. It's also hidden up here. But I didn't use it for such a long time that I might custom folding. Does anybody know where to find this? There's actually test here. I guess you can click it. And then it says create new test. Things like this. Yeah.
How did you first create the new directory for the test?
Okay. That is, you go here. So we first go to your very outer layer. You go to new and you go to directory. Okay. And the next important step is you click on that directory and you say that is for tests. Yeah, that was because this is going to be grayed out for you first, and then you have to mark it as a test directory.
Do you mark it as a test sources or test resources?
Test sources.
And then
And
files going
go test resources. Yeah, precisely. Okay. Anything else? We are going to talk about this a bit later. There are some unit tests here and how to structure. You can look these websites up and you will see, like, we are going to use the Spring Boot as well. Like, they have more tests than actual source code. And even small projects, they have 100 lines of code and 1,000 lines of test code, because it's just really important to, or for many people, it's very important to test. And it's just a very easy way to verify, is this correct? And when you do changes, it says, oh, it still works. I think it didn't destroy something. All I want to tell you is, from now on, try it out. Yeah, please provide unit tests with your assignment. With your final hand-in, I expect that your methods are tested. Yeah, everything that you did for assignment 2, to assignment 5, assignment 6 is a bit special, should be tested. And we'll talk about this in the upcoming weeks as well, how to do that.